Okay, cool. So, just go ahead and tell me like your name and your background, and or they're gonna edit it. So, okay.
Well, Perry Shodash. I'm a third-year graduate student at the Nuclear Engineering Department of University of California, Berkeley. I'm a just got my master's degree in May, and I'm getting my PhD hopefully in a couple of years.
Okay, cool. So, I'm sorry, this is
Fine.
okay. So the first question that we had was you did the study. Sorry, you did the study from 318 to 326.
Yeah.
Were the samples collected outside this period of time, or was it only for that like 1 week? Or?
So we started around 318. We didn't see any radioactivity in the water samples from 318. I think we started at 319, if I remember correctly. We started seeing traces of iodine, cesium, tellurium, radioactive portions of those.
Okay.
At the end, I mean, this was only a side project. This was actually during our spring break. My professor is doing this, and I came and joined in. We stopped doing rain collection at the end because we had other things we had to do, but we were still doing some collection of various foods, usually leafy greens, and we're testing them and saw some positive traces of some of the fallout in the food.
Okay.
Yeah.
Do you think it was like a significant level, or?
No, almost all the measurements were pretty insignificant in terms of health hazard. I mean, it shouldn't be in the food in the first place.
Right.
I mean, you don't want it there, but it's not something to worry about.
And so we were wondering, the time period that outside of the time period, do you think there could have been any additional fallout, like based on weather patterns?
So there was another group here at Berkeley working on measurements, and they continued doing it past when we did it, and they continued through. I think they're still continuing doing it. Okay. Most of the measurements they were trickling off after we stopped, because most of the main outbursts from the reactors were the venting of the gas in the reactors, and that's what we basically were measuring. And so once they stopped venting it, and once they started getting all the gas stopped flowing from it, then you kind of see it trickling off of all that fallout.
Okay. So that was one of my questions. Maybe I misread it, but I thought that it said that it said in the article that it thought, were from the core versus the spent reactor pools.
Yeah.
So that is the case? Or?
Yeah,
okay.
So one of the measurements we wanted to look at was, a lot of people were worrying about the spent fuel pool in Unit 4 of Fukushima. So one way you can look for this is you look at the ratio of isotopes that come out. Okay. So for example, I think we looked at tellurium and iodine ratios. You can also look at the cesium ratio. So there's cesium-137 and cesium-134 released.
Okay.
Both of those are produced in the reactor during fission, the fission products, and they get produced at a certain rate that we know of. If you look at the ratio, so if the reactor is running, they get produced, and we know how much you get produced. But once the reactor stops running, they start decaying, but they decay at different rates. They have different half-lives. So if you look at the ratio, you can tell whether or not it's from something that was just finished, burning, like an operating nuclear reactor, or something that's been sitting there for 10 years.
Okay.
And if you look at the ratio, it's something that's been recently shut down.
Okay. Okay, cool. And then we were wondering if there were any isotopes that maybe your test method was unable to detect?
Yes.
Yes.
There are multiple isotopes. We tried looking for some of those. So what we were using was a detector, high purity germanium detector, which looks for gamma rays. So you can imagine there are some isotopes that don't emit gamma rays. Okay. Or if they do emit gamma rays, they don't emit that many of them. So if there's a really small amount, you can see it. So we tried looking for things that emit beta particles, just electrons. And so we basically took some of the rainwater, filtered it, and put it in front of the detector. We saw some counts of extra counts in our measurement. There was not enough to basically tell what it was. We just know there were extra counts.
Okay.
We also put it into a sample, into an alpha spectrometer, which can tell you if there's things that emit alpha particles, which are normally things like uranium or plutonium and things like that. And we didn't see any evidence of that, although our device was not that sensitive for that. And so
you would probably maybe expect to see that, like things like that in Fukushima and like that area?
Possibly. I mean, you won't, it's really hard, you can imagine, unless there's actually some fire, like the case of Chernobyl, to get uranium plutonium out, because they're extremely heavy.
Okay.
They don't they're not really volatile in air. So it's really unlikely unless you really have some massive, fuel rod fire or actually things melt down and go into the watershed. But.
Okay. So I'll just go on that question. So we were thinking, so in order to avoid the core meltdown, they spray the reactors with water.
Yes.
Do you think that was the best plan?
Yes.
Yes.
That's
okay.
one of the things. You always keep the reactor covered with water. I mean, you can imagine these reactors are about 700 megawatt reactors, electrical. That means that's about 2200 megawatts thermal power. So that's an enormous amount of heat. And once you shut the reactor down, it drops down to about 6.5% and then constantly goes down. But when you're talking about 6.5% of 2,400 megawatts, you're talking about tens of megawatts of heat energy that has to go somewhere.
Okay.
And if you're just sticking it in a small space, it's just going to start melting everything. So you spray a lot of water on it, keep the reactor covered. They threw a lot of boron, you may have read. Boron absorbs neutrons. You want to prevent any chance of the reactor becoming recritical and starting a massive amount of fission.
Okay. Let me see. Okay, so I was also reading a lot of the comments that people were making about the article. So you guys got a lot of press, which is awesome.
Yeah.
But I was also, there's a lot of people making comments. Yes. And one thing I was wondering, so you found it in the rainwater. Can you equate that, in the concentrations that you found it in, to drinking water, food? Does it equate at all? Or?
It's hard to do that.
Okay.
I mean, so it's bioaccumulation of all the isotopes. I mean, you expect it to be, once it's in the rainwater, it's on the grass, it's in the air, so you expect, cows eating the grass, and it accumulates iodine, cesium, they all accumulate in the food. I mean, we did measure spinach and some different greens and grass. We saw it in the greens almost immediately, which is surprising. But the levels are still really low. I'm not a health expert. I'm a nuclear engineer, but it's not something any of the scientists, I don't think, ever changed their eating habits or anything from it.
Okay. So no change in that. Let me see. Okay, so there was a report that 19% of the released C-137 fell on the land, and when most of the rest fell in the Pacific. Most of which is bleeds from the spent fuel pools. So you kind of talked about kind of like a bioaccumulation as far as in our food supply. Mm-hmm. How long do you think we could continue to see that from that event? I know it's probably hard to say,
it's
right?
It's a hard question.
Yeah.
I would like to talk to my professor about that one because he did Chernobyl measurements when that happened. I mean, right now we're barely seeing it. Some measurements from the other groups. Some of the other isotopes in the food, just below our detector limits. Our detectors are really sensitive, and so when it's even below that, that's usually nothing to worry about. I mean, a lot of people were freaking out about what we were measuring at all, but
right.
I mean, these are things that can measure, thousands of atoms in a sample. So.
Okay. And we were also wondering if you had heard anything about any testing that they had done in Hawaii or the Philippines, or.
So the EPA did some testing.
Did they do some testing?
With their facilities. A lot of people complained because they didn't do enough testing that people wanted, and they stopped testing once the EPA said, "Well, this is not dangerous anymore."
Okay.
Some people still think it was dangerous. I know they did in Hawaii. I was looking at some of the results. It's basically like ours. It's really low levels. I mean, most of the plume hit, west coast of the United States. So I know there were measurements done at University of Washington and other sites around here. I mean, there's other measurements people probably have done. Just they didn't publish it yet, or just
taking a while. Let me see. Let me stop it really quick and restart it.